Okay, let's wrap up 8.1 and dive into the topic of confidence interval estimates when the population is not known. So in real-world applications, the population mean as well as the population standard deviation is unknown. This introduces extra uncertainty in the estimation process since the sample standard deviation varies from sample to sample. So we must modify the confidence interval estimation process that we just learned. So while the general format still looks the same with the point estimate plus and minus the critical value and the standard error, we must modify the formula slightly. Instead of the critical z value, we are now working with critical t values. Since we don't know the population standard deviation, instead of seeing sigma in the numerator, we're now going to see the lowercase s, which means the sample standard deviation. So the point estimate is still the sample mean, and to get the critical t value, we will use Excel, but please note that there is an appendix F in the back of the textbook that the chapter will refer to. If you prefer, you can use that to get the t critical value, but in this video, we will use Excel. To get the critical t value, we also need to know the degrees of freedom, which we'll discuss in a moment. So the standard error is structured similar as before, but we're just going to be using the sample standard deviation now divided by the square root of the sample size, or n. So we learned how to calculate the sample standard deviation in chapter 3. For reference, here's the formula to calculate it in Excel. So how does the t distribution and the standard normal distribution compare? As you can see with the turquoise curve, the t distribution is wider or more spread out than the normal distribution because there's more variation when we're working with samples. Both the standard normal distribution and the t distribution are bell-shaped and symmetrical. There is only one standard normal distribution, but there are many different t distributions depending on the degrees of freedom. So the degrees of freedom represents the number of independent pieces of information used to calculate a sample statistic. It is based on the sample size, so depending on what the sample size is, we will get a different t distribution. The t distribution is more spread out than the standard normal distribution. You can see the standard normal curve here with the black line. This graphic has 4 different t distributions with degrees of freedoms of 1, 3, 8, and 20. As you can see, as the sample size increases, the t distribution more closely matches the standard normal distribution. So we calculate the degrees of freedom as the sample size minus 1. So let's look at an example. The distribution of overtime hours per week for employees at Legoland is normally distributed. A random sample of 10 employees is selected, producing a sample mean of 4.5 hours and a sample standard deviation of 1.3 hours. Construct and interpret a 95% confidence interval estimate for the population mean. So the point estimate is the sample mean, and that was given to us in the story as 4.5. The degrees of freedom is calculated as a sample size of 10, and then we subtract 1, and that gives us a degrees of freedom of 9. The sample standard deviation was also given to us in the story as 1.3. The only thing that we don't have in the story is the t critical value. We will use Excel to calculate that next. We saw this before, but alpha is 1 minus the confidence level. So for instance, a 95% confidence level would have an alpha of 1 minus 0.95 or 0.05. We will use this function in Excel to find the t critical value. The formula is equals t.inv.2t, and then you enter in the alpha and degrees of freedom. You will see we are consistently reminding you that the degrees of freedom is sample size minus 1. So here's an example of a 95% confidence level with a degrees of freedom of 9, and we get a t critical value of 2.2622. We can also find the margin of error, which is the right side of a confidence interval estimate formula. We would use confidence.t function in Excel and enter in the alpha, sample standard deviation, and sample size. So here is an example for a 95% confidence level, 1.3 sample standard deviation, and 10 sample size. And we get a margin of error of 0.93. So let's go ahead and continue with our Legoland problem and calculate the confidence interval. To find the t-critical value at 95% confidence based on a 9 degrees of freedom, we would use t.inv.2t function, plug in the alpha of 0.05 and the degrees of freedom of 9, and we get 2.2622, the same as the example we just walked through on the prior page. So now we can go ahead and plug in our variables into the formula. We have our sample mean of 4.5 overtime hours, plus or minus the t-critical value of 2.2622 that we just calculated, times the sample standard deviation of 1.3 divided by the square root of 10. So to the right of the plus and minus sign is the margin of error. We can either do the math or use Excel using the function confidence.t and input the alpha of 0.05, sample standard deviation of 1.3, and sample size of 10, and we get 0.93. So we now have 4.5 hours plus and minus 0.93. This gives us a confidence interval of 3.57 hours to 5.43 hours. Based on this sample data with 95% confidence, we can conclude that the population mean of overtime hours is somewhere between 3.57 hours and 5.43 hours. So just remember, when the population standard deviation is unknown, the main difference from what we did earlier in the first video is that we must find the t-critical value instead of using the z-value. Let's wrap this up and do another problem, 8.9. A random sample of 12 values was taken from a normally distributed population. Use the following sample to construct a 95% confidence interval estimate for the population mean. So in step 1, we just want to define the sample size. So this was given to us in the story as 12. You could also count up the numbers given here. So in step 2, we want to make sure we identify the confidence level. So in our story, we were told that what we want is a 95% confidence interval estimate. So in step 3, we do need to compute the sample mean and standard deviation for this sample. So using Excel, you want to input all of the numbers from the sample and then use the average function for the sample mean and the standard deviation.s function for the sample standard deviation. So we get 102 for the sample mean and 6.89 for the sample standard deviation. Now in step 4, we must determine the critical t-value using the 95% confidence level that we just confirmed. And again, the degrees of freedom is the sample size minus 1. So we take 12 minus 1 and we get a degrees of freedom of 11. We will use Excel to calculate the t-value again. So we input equals t.inv.2t and then the alpha or 1 minus 0.95 for our confidence level and then 11 for the degrees of freedom. And we get a t-value of 2.201. So here is the formula and we'll need to plug in our values. We would take the sample mean of 102 plus and minus the t-value of 2.201 times 6.89 for the sample standard deviation we calculated on the prior slide, then divided by the square root of the sample size of 12. So this is our margin of error. Again, we can either do the math or use Excel to calculate the margin of error. I'll go ahead and show you it again using Excel. So we input equals confidence.t with an alpha of 0.05, 6.89 for the sample standard deviation, and 12 for the sample size, and we get 4.38. To wrap it up, the confidence interval for this sample of 12 numbers is between 97.62 and 106.38. Well, everyone, that wraps up this video on confidence intervals when the population standard deviation is not known. In the next video, we'll learn how to calculate required sample sizes.